There's 5 and
Please come to
4th.
the layer 1, sir.
Huh?
Layer 1, sir. Please come to the layer 1.
Yes, yes. Yes, this
Yeah, this
portion is done.
screenshot taken. Yeah.
Okay, then we are having this portion. Layer 4, 3, 2, 1.
Layer 1.
So layer 4.
Sir,
Over here.
Yeah. Okay.
please just
Then
scroll
we
down,
have
sir.
layer 3, layer 2.
Okay.
Please just
Done.
scroll down, sir. Layer 1.
Okay, and this is your layer 1.
Oh,
Taken.
Yes, sir.
layer 1, sir.
This is your layer 1, right? Can you see?
Layer 2. I am seeing layer 2, sir, here, sir. Please go. Yes, now I am seeing layer 1.
Okay. Take the screenshot first. Taken. Finished.
Sure, last layer. Fifth sound layer.
Which one? Which last layer?
Fifth
This one.
sound layer.
Simply just take the screenshot. You guys have taken the screenshot or what? Can I minimize this now?
Yes, sir.
Yes, sir.
No. So this is your OSI project over here. Let me just load it. So as you can see that we are having this is your sender machine and we have this receiver machine available over here. Okay, so this is your complete picture over here. This is our system interconnection. What exactly we are defining as a framework. Okay, a framework is nothing but simply just sets of rules and procedures. What exactly we have, where exactly we have these two approaches. What we are following in this particular model. Top to bottom approach exactly means that layer 7 to layer 1 we are following, and bottom to top means layer 1 to layer 7 we are following. This is physical replication. This is your NIC card. What exactly you are having on your system, which is responsible for making that communication, like the request and reply done through NIC card. This is your hardware. On the
What is
system,
the
it
full
is there.
form of NIC, sir? NIC full form, sir?
That is your network interface
NIC?
card. Network interface card. Okay, this NIC stands for network interface. Okay, and this particular card always you must have in your system. When it comes to sender, receiver, or request reply communication process, all this communication always is done through this card. This is hardware. This is basically the port where you connect your internet cable. Okay, on your system you are having an internet port, right? This is your LAN port, and this is the port where you are connecting your internet cable. Simply, this is your NIC. Okay. So all these are connected via cables. As you can see, we are having all these cables getting connected from one system to another system. And this is the cable where exactly our voltages, okay, our signals are converted into voltages and it is getting sent from this machine to this machine. And this machine is receiving it on its NIC and it is processing all those voltages from here to here, from here to here, like that. It is going up in double layers, it is getting presented to the application layer. So all these informations, when it is getting generated from like layer 7 to 6, 5, 4, 3, 2, 1, all these layers they are performing their functions. Okay, so layer 7 basically gives you the application interface by which you are communicating to resources. Means whatever information you want, you can simply just type it on your Google browser, okay, web browser, and you can simply access it. This is where different types of web browsers what you are having, like Google Chrome, Microsoft Edge, Mozilla Firefox. All these are your web browsers what you are using in order to like what access Google or Facebook or Instagram. All this it requires an application. So this application it's like what browsers. Okay, browser applications is coming as an example over here. Okay, application layer always gives you that platform by which you can access this type of like what resources on internet, okay, or any network. So this application layer is the first layer from which exactly the process of generating the request it starts. Okay, after that it comes to layer 6. This is where you are having the presentation layer, and this layer 6 basically presents the data to the application in a more user friendly manner, like converting the machine language to human language and human language to machine language, because the system understands machine language and we as a human we understand alphabetics, okay, pretty well. This type of languages, okay, needs to be converted, okay, in order to understand what exactly is the request we are sending and what reply is coming to the system. This interpretation always is required, okay, system to human language to system language. So system language, that is your binary, 0 and 1, right? You are having the base 2 number system, and this particular binary system always is being used, okay, in the organization. In the organization's network, always you are having the communication is going on through these bits, okay. Even if you are setting up a network, you are also doing communication in terms of bits only. Bits is nothing but zeros and ones. That is your binary based 2 number system, and that is your machine language. What exactly over here the system understands only, okay, human language they don't understand. So alphabetics and those numbers, those 2 digits, that conversion is being done in the presentation layer, okay. And similarly the presentation layer is also performs the compression decompression, okay. When you were sending some informations, some file to this machine, then let's say that the file size is 1 GB. So when you were sending it, you were compressing the data to 500 MB and you are sending it to this machine. Okay, so 500 MB file size, it will be going faster than 1 GB. Compressing always, it helps the data to be moving faster when it is moving from one side of the network to another side. Always it can be sent faster. Encryption, decryption facility is also provided. Like every single information what you are sending, this information is always it is getting encrypted. And encryption is nothing but simply changing the format of the data. The format of the data means whatever information we are sending, it will be totally encrypted so that no one can read it. No one can understand what exactly we are sending. When you visit google.com, all the information, what exactly you are having on Google, it is encrypted. So no one comes to know that what exactly you have entered, which website you are visiting, and no one will get that information. It will be totally encrypted between your machine and the Google server machine. These are the main functions. Okay, encryption, decryption, compression, decompression, understanding the nature of the data, what exactly we're trying to access. These are the most important functions. Okay, conversions of data from human language to machine language. Because systems only understand machine language only, but we are not comfortable with machine language. That is why we are having our language and the systems that are having their language. This conversion of data between human to machine to human is done by the presentation layer. Next session layer, we are having the creating session, maintaining session, terminating session. This is the most important 3 functions what you need to know regarding session layer. Okay, creating a session, maintaining a session, and terminating the session. Whenever you are trying to access any website, okay. So first of all, the server of that website, okay, will establish a session with your machine, and it will maintain the session. Okay, the moment you access the website, this is when exactly the session will be terminated. Okay, for example, if this machine wants to communicate with this machine, then first of all, a session will be there between this machine and this machine. The moment he will be like what done communicating with this machine, maybe he wants to download some file and he has downloaded it. So the moment he's done downloading the file, he will simply just close it. Okay, and during the opening and closing of the session, there is session maintenance. Okay, means the moment till downloaded, it is getting like what the session is getting maintained. And when the file is downloaded, this is when the session is getting terminated. This is what we will have in the session layer functionality. Okay. So session is always important, okay, because of the fact that unless we are having a session, we cannot exchange informations, okay, with multiple machines. That is why session creating session is always important. Coming to the transport layer is pretty much responsible for doing segmentation and sequencing. This type of informations, like this is your actual information, which is divided into small pieces. These are called as segments. Okay, all these pieces are called as segments, and this segments always is given a number. Okay, sequence number, because segmentation and sequencing is one of the major function of your layer 4. Okay, this segmentation is nothing but dividing one big packet of information into small pieces, and every single pieces you are having the sequence number, which is always added. Okay, and this sequence number is always okay, because when any segment is not reached, okay, let's say that it is not delivered properly or it is lost for some reason, this is when exactly transport layer can retransmit this sequence number 3 again. Okay, this segment number 3 again, it can be retransmitted if this segment is not reached, okay, or it is not delivered to the destination. Always whenever you are sending any information, always it is going in this particular format, in these small pieces. Okay. Similarly, we are having flow control and error control. Flow control, it is always making sure that whatever data we are sending, the device, okay, the receiver should be able to receive that information. If we are sending 100 MB data per second, then the receiver should be capable of receiving 100 MB per second data. If he is not capable of receiving 100 MB, then it will be a problem, because excessive amount of data will be sending and the receiver will not be able to receive that. That is why XML flow control makes these two systems decide that what rate exactly they should be sending the data, okay, with each other. Because if this device's capacity is 100 MB per second transmission speed, and if this device's receiving capacity is only 10 MB per second, then when he will send 100 MB, he will not be able to receive 90 more MBs, because 10 MB per second he can receive it. Okay, so it is beyond his capacity to receive like what 100 possible. This is why exactly they will be negotiating that at what rate exactly they will send and receive informations. Okay, this is the controlling of the flow of the data, what exactly will be sending and receiving. Error control, simply this is your retransmission, as I have already told you. If any particular segment is lost for any reason, okay, this is when exactly it will do the retransmission. Okay, for example, if any if it is lost, then this particular packet, it can be retransmitted back from this particular system again to this system. Retransmission is the only way by which error can be controlled. Okay, because when you are sending packet, it may contain errors. Okay, it may there may be existing some problems, some errors, it may exist. Okay, so if there is any errors in the frame or in the packets, this is when exactly this retransmission is being done in order to retransmit the informations again back to the receiver, okay, from the sender side. Sender and receiver always exchanges this information. Okay, transport layer is one of the major layers what we are having. TCP and UDP, these are the protocols. TCP is considered as slow, UDP is fast, provides guaranteed delivery, UDP doesn't. TCP provides acknowledgement, UDP doesn't, and connection oriented and connectionless. Connection oriented means always acknowledgement you will be getting whenever you send anything, you get an acknowledgement. And this is the TCP three-way handshake process, which basically provides that. Okay, so first way, second way, and third way. Once this third, all the three ways are completed, this is when connection is declared established. And when the connection is declared established, this is when they will be sending data, they will receive acknowledgement. So these are basically determined based on the port numbers. TCP UDP port number range 0 to 65535, where we have the first 1024 port numbers reserved for protocols or services like HTTP, FTP, all this what exactly we were saying. These are basically protocols or services. For all these numbers, you have this range reserved. So 0 to 1023, then 1024 to 49,151. It is reserved for software application development, means those organizations who build softwares, okay, for network access. This is for them exactly, it is reserved. And those machines, okay, like our systems, okay, when we are accessing internet, then we also need port numbers. So this is why exactly this port number range is given. So 49,152 to 65,535. This is the entire range which is reserved for dynamic usages. Means when your system is sending something, it requires a port number. Always remember the source and destination port number must exist. Whenever you send any segment, at the time the segment contains this information. Okay. Whenever you send a packet, your packet contains IP information. When you are sending any frame, your frame contains source and destination map information. These are the informations. What exactly is there? Source and destination always is there. And this transport layer basically does all these functionalities. Okay, it is considered as the heart of a model because it is simply just sitting in between these upper layers and these lower layers. So these are the below lower layers and these are the upper layers. In between this, it is just sitting. This is why we consider it as the heart of the OSI model. Okay. Coming to the network layer, everyone, this particular layer's job is to perform routing. Routing means how the information needs to be delivered from this machine to this machine. Okay. How the information which needs to be routed from this particular line to this line. Okay, routing always is required. Finding the best path to send your information. Okay, if you want to reach a particular destination, then how exactly you can reach? Okay, how to find the route which is best to go to the destination. This is what exactly is the calculation which is performed by this network layer, everyone. It's called routing. Okay, and network layer also provides logical addressing because they are part of a network. They need to be identified. This machine should know that who is the machine to whom he is sending the packet. This is the network layer, which basically does provide the IP addressing information. Okay, IP address is your logical address which you are using in order to identify every single devices on your network. Now, since every single device is like what coming in a network environment, it is always important to uniquely identify these devices with the IP address. Okay, a network layer logical addressing information always it is your IP address. And the device, what exactly is performing in this layer is this router, everyone. This is your router device, and this type of devices always it is in charge of doing routing and finding the best path to send your packets to the destination networks. Here's what these routers they are doing. Coming to the debugging layer, everyone, this is the layer where exactly our informations from layer 7, 6, 5, 4, 3, all these things are converted into frames. Okay, these are basically a big envelope, and from layer 7 to 3, it is getting inserted into frames and it is delivered to layer 1 for physical transmission via this cable. Okay, these are the informations what exactly is getting inserted inside frames. Okay, so frame is nothing but simply just an envelope where you are getting all these informations from 76543. Okay, all these informations are inserted, and layer 2 specifically the dynamic layer provides that MAC addressing information because these are hardwares which needs to be identified because whenever we are sending it, we are receiving it over here on this hardware. So these hardwares are having addresses. These are called your physical addresses, and this led to provides these physical addresses directly to frames, so that like what the system can understand that for which particular machine the frame is coming, for which particular machine the frame is going. Okay, all these physical addresses always is being provided by this layer 2. Okay, so this framing process is basically the main objective of layer 2. Okay, to like what to put all the things okay with what is coming from layer 7 two layer to all the informations. It is grouped together in a frame, and it is basically given to layer 1 for physical transmission, okay, in terms of signals by this cable, and it is getting received on the receiver side. Okay, this is what you are having the switch and bridge. This type of devices like switches. Okay, this device bridge device you are having. These are the types of devices like bridge. Okay, these two types of devices are basically used. Okay, in data link layer. Okay, and data link layer basically works directly at layer to level, and main function of this particular layer is to include the hardware addressing information, that is your MAC addressing information, to frames whenever they are sending information to any other machine. And similarly, these are permanent addresses directly found on the NIC card itself. So these are physical addresses only, and always this address is required to deliver the frame to the correct machine. Okay. So physical layer is simply just doing the conversion of those data, okay, what we are getting from all these layers. Simply just it is doing the conversion of this data into electrical voltage signals, and these voltages are flowing by this particular cable and is getting received over here. Application presentation session transport network data link and physical layer, everyone. These are pretty much like what the very short definition what exactly we are getting. Okay, but in a very casual manner you can understand what exactly you are having the 7 layers model and what exactly it is doing. Okay, the entire process over here, it is about sending and receiving information. Okay, and this is what the same model what we are having over here. This is the TCP IP model. Basically, we are having all these layers from here coming in. These are the top 3 layers what we have representing using application layer. This is your transport layer. Then we are having network layer. Then we have the data link and physical layer. Okay. These are the layers. What exactly is coming up? This is your TCP IP model, everyone, Department of Defense. Ultimately, every single layer what you have this okay, what we you have studied in this OSI, okay, 7 layer model. This is the same thing what is coming over here, but the number of layers are less. Instead of 7 layers, we are right now having only 4 layers, but all these layers are coming together as one unit, and they are basically performing the functions. Okay, so these days what exactly model we are using for doing communication is not OSI model but TCP. Okay, so the functionalities are pretty much the same functionality what you are having over here in this model also. The only difference is multiple layers are right now functioning in one single layer, and they are basically doing the job. Okay, and when we are functioning in this manner, this is when exactly the time consumption is also less. Like from this layer to this layer, all these layers we are crossing to generate the request. Right now, only we are crossing 3 layers, and that's it. Now the function is getting sent or received. This is the TCP/IP model developed by Department of Defense. This is the US organization who has made it. All you have to know is this layers functionalities, everyone, to ultimately know these layers. Okay, application transport or host to host, internet layer, network access layer. These are the layers which is ultimately the combination of these layers. So know these functionalities and ultimately you know these layers. Okay, this is about your TCP/IP model, everyone. The layers functionalities I have given you the description over here. Okay, just go through it. Okay, here you will be understanding how exactly all these layers can function properly. Okay, everyone understood?
Yes, sir.
Yes, sir.
Okay, now next,
Sir,
tell me.
sir, please repeat a network layer.
Network layer, you know IP address, IP address, you know. Yes, who has asked this question?
Hello.
Swapnil,
Uh,
you have you heard about IP address, Swapnil?
yes, sir.
What exactly is IP address? For what reason we use it?
IP address logically identify the devices.
Identify the devices. No, this is what network layer function. Okay,
Okay.
network layer basically performs this. Okay, that identification using IP addresses. And second is to find the best route. Okay, find the best route from source to destination. How to find the best route? This is the network layer which does that. Getting my point?
Okay. Okay.
If you
Yes.
have multiple routes, okay, if you have multiple routes from source to destination, then which route is the best? This is what exactly network layer finds out. This is what we call routing.
Yes.
Okay,
Yes.
And
okay.
sir,
So now,
sir, in data link layer, you said that that data link layer will associate the physical address with the frames, correct?
yes,
So, what is this physical address?
physical address, that is your MAC address.
Then NIC card address, you're saying?
NIC is your hardware, na?
Yeah.
And in the NIC address is found. That is your MAC address.
Okay. So, why it
Okay.
is required? Why it is required to attach this?
Because physical address always is required. It's a permanent address, na? IP address is a logical address. It is not permanent. Any time you can change it. But physical address, it cannot be changed. It is directly burnt on the hardware. It is directly found on the hardware. If you want to change the physical address, you need to change the hardware itself on your machine. Otherwise, it is not changeable.
Okay.
Kind of more reliable. Think of it like this. Kind of more reliable because you kind of get a guarantee that whatever address you are using, the physical address, it is not changing during communication process. But IP address, you can change it at any given point of time because these are logical things.
Sir, we can change the MAC address. Is it possible?
Temporarily, you can do that. Temporarily,
Okay, okay,
not
sir.
permanently.
Okay, sir.
Okay, you cannot change it address. Huh? It's called permanent address.
Yes,
That's what
yes.
that is. Okay, any more questions? Okay.
So, one more thing.
Tell me, Bhaskar.
Sir, the this actual session is getting established on which layer? Session layer or transport layer?
Session layer, session layer.
But
Over
in
here.
transport, okay. But in transport layer, 3 packets, correct? Like you mentioned,
It is
that
not.
synchronization packet.
Transport layer is about establishing connection oriented type communication or connection less type communication. This is connection oriented.
So it is
Connection,
not representing the
establishing
session.
connection. No, it is not creating the session. The session is already getting created. No? Over here, what is getting decided is whether they want to make communication in this like format, or they want to just communicate using just sending data and never receiving acknowledgements. Connection less or connection oriented, in which type they want to make communication. This is getting decided. Session is already created over here. Na? In the session layer itself, it is getting created.
So how it will be decided then that TCP will be used or UDP?
It is decided directly on the application. Na? If you are downloading a particular file using FTP, then TCP using Gmail, then you will be using TCP because these are protocols, right? Working with TCP. Yes or no? Just look at the chart. Yesterday you have taken a chart, right? The common
Yes.
used TCP UDP port numbers, remember?
Yes.
Over there you have seen, right? SMTP, FTP, all these port numbers are there, na?
Yes.
It is defined directly in the service you want. Do you want to download files? Do you want to send emails? Do you want to browse web using HTTPS? For all this, it is defined that which particular port number should be used, whether TCP or UDP should be used. Everything is defined. You just have to know. Getting my point?
Okay.
Okay, everyone.